All right. First of all, I just want you all to be aware, to pay attention on the talk, maybe think on some questions, because at the end, we are going to give away these books. The rule is ask a question. If it is a relevant question that is targeting our talk, you just pick a book. Just don't pick 2 books. But let's see about our content now. Okay? Yeah.
Should we wait for questions?
Yeah, I think at the end will be better because we have a tight time here. But hold it to the end and can go through all of them. All right. So the talk is about clean architecture essentials. In a few words, it will hold these subjects. Introduction to the definition, hexagonal architecture, plugins, guided by tests, focus on use cases, and going deep in a sample application. So these are the main subjects that we are going to discuss here today. This is me, Ivan Polovic. I'm moved to Stockholm about 1.5 years ago. I used to be a Microsoft MVP. I work for Nordex Bank, and I really enjoy Stockholm. It's a very nice city. But actually, I'm a Brazilian, so I'm not despise my name. I'm not Russian, so it's Brazilian. And I need to start making some provocative statement here. It's about software architecture. We usually to see in job descriptions describing software architectures, applications, descriptions like that. We define an application by its layers and the frameworks it uses, right? I'm not taking anything from out of the blue here. I've seen many descriptions like that before. And I have a strong statement here, and I'm going to sustain the idea along the talk that this is not software architecture. And I'm going to explain why and how you can improve the software architecture in a different way. Looking at this picture about it's a blueprint. Looking at in just a quick glance, you can suppose that it is some kind of a church, or a theater, a place that people can gather together because you have this open space. Many people can gather together at the same time. Have these big doors. Many people can leave, enter very quickly. We have all these benches pointing to the same direction. By the usage, you can guess that this is a church. Definitely, if you see a blueprint of an apartment, of a house, you see bedrooms, kitchen, living room. So how people use that space. And the blueprint gives you an idea very clearly what is it. The challenge in software architecture is that we usually don't do that. We usually hide the usage behind technology details, implementation, frameworks. And how can we do different? And I need to introduce, and I think what is the main tool that will help you build software architectures that is guided by usage is clean architecture, because in a clean architecture, the use case are the central organizing structure. The hexagonal architecture is a given, so you need to comply with the hexagonal architecture principles. So implementation guided by tests, decoupled from technology details. So the hexagonal architecture is a given to achieve a clean architecture application. Of course, the subject here is not simple. It's very dense. So there are lots of principles to achieve a clean architecture. Standard abstraction principles, stable dependencies principles, solidity principles, and many others. And clean architecture puts an effort on decoupling the user interface. So all these tools we are going to discuss here, and the first one is about use case. Application use case, at least there is this structure that if you look at this description, because this is the first description that I'm showing to you, a ticket terminal that has this few use case: display movies, request movie details, print, order ticket. So there is a customer that interacts with this use case, and this use case affects secondary adapters. In that case, movie catalog, order system, credit processing. The interesting thing about use cases is that they are delivery independent. Looking at this use case, you can assert that it is a mobile application or maybe exactly a terminal that is running near the movie theater. But the main focus of a use case is to show intent. When you list use case, you can grasp what is the system what the system do. And as any use case, there are an input. This input is processed through an algorithm, and it should give us an output. Looking at this picture, just to clarify, because we are going to discuss this, there are primary and secondary adapters. Primary customer is the one that initiates a conversation with the application, and secondary actors, the ones that are affected by the system. So in general, we can see that hexagonal architecture also requires a decoupling. There are business. This business lives inside the application, and technology implementations that lives outside of the application. So in this picture, we can see that there is a user. Through the user interface, it can interact with the business rules. And we can see that each side of the hexagonal have these adapters. In that case, we have a in-messaging repository or in-memory messaging and a cloud messaging, both achieving or giving the same feature to the application, which is give some messaging mechanism. Looking at this picture, we can relate to the previous one that there are primary actors and secondary actors. And we are going to dig into the hexagonal architecture through this talk, but let's move forward. In the previous picture, I show you the use case as a visual representation. How should look like a use case? First, this is a register use case. We can see that we can't actually find a natural language to describe a use case. So we need a programming language that will serve as an algorithm to process the input, do some business logic, and generate some output. So I can't promise you that you are going to design applications with natural language, but it will be closer to, in a way that you can see these lines and identify what it is doing. And I hope that you can see on the right side there is a source code tree that is showing a few use cases like close account, deposit, register, transfer, withdrawal. This is the source tree of a project that I have on my GitHub. If you guess what this project do, it's like a wallet application that you can manage certain balance, account balance, right? And in the introduction, I showed you that to understand clean architecture, we need to go deep into lots of principles. I think that the best way to learn these principles is showing few examples, and through these examples, we characterize what principles are being applied, and later on, we are going to understand exactly these principles. But this first slide, we have an iAccount repository and account repository class. The iAccount repository interface is highly abstract, so it's a very general concept. So it is also stable, because usually an interface has no dependencies, or at least these are minimal dependencies. On the other side, the account repository is very concrete. It is sealed, and it depends on some kind of context. In this case, we can see that this is there are SQL scripts, entry framework, context. So all these are very concrete, very specific to deal with SQL Server database, and it uses entry framework to provide the capability of the application. So this is also unstable because it depends on certain interface. It is given a capability to interface. The next example, we have actually here three examples. So there is the register request. It is actually very concrete. In this case, inconsistent, because we have these getters and setters, and very specific. We can imagine that this class is being used in a web API or some user interface layer. So it is very inconsistent and concrete and specific. On the bottom, there is this iAccount interface, very abstract. It's an interface, it's highly abstract, very general, and stable. And in between, we have this register input. By not having these setters, it is more consistent, right? So you can have it in a validated way through the constructor, and less specific than the register request, right? At this moment, I hope that you have on your mind a visual representation through a spectrum. Like, there are objects that are more concrete, more inconsistent and specific, and on the other side, we go to a more concrete, consistent. On one side, we have a very concrete, inconsistent, and specific, and in the another side of the spectrum, an object that are very abstract, general, and stable. So there are objects that has different properties. So I guess that you all have seen some similar picture, mostly from Uncle Bob. He has a very famous post about clean architecture. Going back to that property that we saw before, we have this more abstract, and these abstract objects should live in the inner circles. The more concrete, it should live on the outer circles. More specific on the outer circles, more general on the inner circles. So the two rules on these principles are abstractness increases with the stability. So the more stable, more abstract. The more stable, more abstract, it should live on the inner cycle of the clean architecture representation. More concrete, more specific on the outer side of the clean architecture representation. So these layers gives you that. So what I'm trying here is to, sometimes we create abstract objects, sometimes we create concrete objects. And sometimes we found these very concrete objects in the inner cycle. And by having a very concrete as in the use case or in the entity, and by not using some kind of interface that you can create an abstraction of it, you lose opportunity to create more specific objects. And the same happens when you have very abstract objects in the green side. So if you have a very abstract objects living in the UI, database, or web, you also need to create more concrete objects there. Usually you are leaking some abstraction to the outer layer. So they gives you certain smells. But moving forward, this is a slice of that pie. So we can imagine that more abstract, general, stable, more consistent. It moves closer to the entity sides, and more concrete, unstable, inconsistent, to the edge of the application, closer to the UI or to the adapters. And now we need to go deep onto this plugin argument. So just to introduce the idea is that on the green side, we have these highly abstract objects. So we have this iOrder ticket, it's an interface, and iTicket repository is another interface. We can see that there is the user interface and infrastructure layer are very concrete. They are implementing these interfaces very specific to this to the UI or to the database. And we can see that the core layer is independent. So I'm not giving you anything new here, I guess, but just to give us the base to continue investigating this. I'm going to discuss these plugins that you create your application, and to justify that, I'm quoting Uncle Bob about deferring decisions, deferring implementations, leaving options and decisions open as long as possible, because I've seen this a lot. I have to create an application, and I think the first sprint or the second sprint, we are discussing the best database schema, best technology to connect to the database. And of course, we can find arguments to say SQL Server is the most appropriate, a NoSQL database is the most appropriate. You can find lots of arguments to both. My point here is that either option is the second best that you should implement. The first one should be fake storage. So following the idea that if you need to implement a dependence, you don't implement the concrete one or the real dependent on that technology. You go and implement a fake storage that gives the illusion of a database. Because by having this mindset, later on, you can, when you have more information, implement the real SQL Server or NoSQL. But be aware that in the future, probably you have a cloud service that will give you the same capability. So designing an application to be changed, it's a good mindset. So, and that's the first strategy of development that I want to propose, is that you implement your use case guided by test cases. If you find the necessity of implementing a dependency, the first one that you should implement, instead of going to the real one, you go to the fake, implement it, get feedback, learn from the usage, and then later on you can go to the real dependent application. So there are a few principles here. It's like the test cases will guide you to find the best interface for your use case, basically applying interface segregation principle. And use case implementation should at least follow the single responsibility principle. In other words, being responsible for only one actor. So that is the summary of these principles. And it's very important that your test suite also reflects the usage. So it should expose usage in the higher context that you have. In this case, we have use case tests, but maybe we could have called it wallet tests, because sometimes I find more useful to explain on that way, but you can give to each context the context name and expose on each folder some kind of what are the testing there. Of course, unit tests are not enough to show that the application works. I recommend that you test integration tests going to the real implementation. So if in a later moment I found that I'm going to use Entity Framework to consume a SQL Server database, that tests should target that component from the iRepository interface, somewhere near there. And the use case targeting the usage. And a minimum set of tests you need to have to prove that all the parts are tied together through acceptance tests. I talked before about fakes, but I don't want you to have on your mind that I'm talking about mocks. Like, at least on my experience in .NET, we have MLQ. It's a good library that you can create like mocks for specific methods and provide a behavior for that specific test. When you do that, or at least when you have lots of it in your tests, they lose the readability. So what I'm proposing here is that if you need a default behavior, the first thing that you need to create is a concrete class that implements that interface. If you see here, it's very similar the way we will do with Entity Framework. But can you see that the collections here are in memory? And it is not using Entity Framework at all. This when you add an object here, it is adding to a collection of customers, which is in memory. So what I'm saying here is that a fake implementation gives you the illusion of the real implementation in a way that you can run your application against it. And that's the case about components. So later on, when you decided by the technology that you are going to use, you can implement the real like the real database, the real user interface, using the concrete libraries and frameworks, but implemented isolated in a way that you can replace, upgrade, or decommission, and always looking for losing coupling. What I'm saying here, in other words, at least if you are from .NET, at least closer to your startup, we are going to have a method like this. You have this add dependencies in adding to the SFC collection the specifics implementation. What I'm saying here is that you can have on your startup, on the beginning of your application, deciding if it is a development or if it is a production. If it is a development, run your application against the fakes, because they can give you to your user at least an environment that they can see, get feedback, see if you implemented the business rules that are more important. And later on, to give, when you decided what persistent mechanism you are going to use, you switch to the real SQL Server persistence. And you can do that for many other dependencies. The workflow to work with this is like, I have this hexagonal architecture representation that I should begin with unit tests. These unit tests will target certain interface. This interface is a use case, and this use case much probably will need some a remote service to access a web service or to access the database. By the picture, we can see that the web component, instead of going to the web, because it's like leaving the application but going back, it actually didn't go to the web application. And the database, I'm doing the same. So it is a fake representation of a database and a fake representation of a web service. I can run it, I can get feedback of it, and I can change my use case with that feedback. Later on, now I'm more responsible about my code. Let's create the concrete database implementation. Later on, let's create the concrete cloud service implementation. And the last thing that you need is a user interface. Just connecting to the previous slides, we still have primary actors, secondary actors. That is the vocabulary that we're going to use here. Another strong statement is about frameworks. They are very good. They give you productivity. They solve common problems. But you shouldn't design your application targeting. When I say application, it's the application use case. Everything that is business level, high level. So you shouldn't design use case targeting frameworks, targeting libraries, even the .NET framework. You shouldn't be coupled too much to it. Reflection, link, anti-framework, MVC, data annotations, they are very useful, but you should use them in the correct place. Definitely not mixed with business rules. And I can't give you all the examples how to protect your application against these libraries. But here, just to share an idea, this is a concept called first class collection. Is when you encapsulate a collection and expose only the methods that your application needs. So instead of using iList of credits or a kind of a collection of credits in my application, I design a credits collection. This credits collection expose an add method and expose the get transactions and the get total. So by doing that, I'm removing from the application that we usually have this contains, remove, add, all this noise that you can use, and maybe you have different behaviors in different places, or you are reusing link queries in different places. So encapsulate these dependencies, use them behind certain interface that you design in your application. And the another challenge that we have in a clean architecture is to make the user interface a detail. This code here is very simple, but it's just to make a point. This is for the .NET developers. This is an action that lives in a controller. And this action is getting account details. The use case here is a service that retrieves it. And following this implementation, it can throw an exception, or if you found the object in the output, you return the object itself. I guess everyone here maybe found similar code like that and found your own ideas how to make it less noisy. And I want to propose something here. First of all, I wanted that my use cases or my controllers look like I'm gonna receive. On the left side, I have the same action get in the controller. It will create this input that is very consistent. It gives you to the use case, and I have a presenter object that will be responsible to render the view model. The interesting thing here is that we don't have this connection, like I execute a use case, I get the output, I need to unwrap it to read the properties or maybe check for null and decide what to do. In this case, I execute the use case, and the next step is presenter. What is the model that I should give back to the user? To achieve that, on the right side, I have this get account details. We can see that in case of the repository can't find it, I'm going to invoke the method output port .not found because it doesn't exist. And in case of it exists, it will call the standard output. All right? The interface that this use case is using is the iOutput port. The same interface that the presenter is implementing. It becomes to be more clear when you see the presenter. First thing is that previous implementation, original implementation, was giving back the output to the user. Whatever it exists there, the .NET will serialize it and give it back as JSON. The presenter object here, the implementation is, it implements the output ports, the not found and the standard, and it knows what is the output message, and each method is responsible to generate the view model object. So one method or another will be invoked, and the controller just needs to say, give me the view model. The UML representation of this components together is like accounts controller sees a use case. The use case contract is implemented by the get account details use case. In certain moment, the use case implementation will invoke the not found or the standard output, giving a message back, and the controller use the presenter to just ask, what is the response object? On my journey to this decoupling the user interface, I found different strategies. You can create observable objects. This is the pattern, or at least the one that is proposed on Clean Architecture book from Uncle Bob. And that is how it's supposed to be. Instead of giving back an object, you invoke a method that is used by the presenter. Sharing with you guys, I have a sample application. I think every developer needs to create a to-do application to manage your life, your tasks on the day-to-day. And I am a .NET developer, and I needed this. I needed to add a task, list them, mark them as complete, mark as incomplete. But as a .NET developer, the first thing that you need to do if you are a .NET developer is, let me create a web API. But this is the mindset that I want to change. So I said, I don't want to do that. I already did it many times. So let me do this different. Turns out that the final application that was good enough for me was this terminal application that you can add tasks. Every task that you add are sent to GitHub. Actually, it's a private gist file. And I can mark them as complete, unmark them. It is like good enough for me. But I learned that was good enough by following a different mindset. So I focused my implementation. So I split the application in 3 axes of evolution. So one is the use case. So the use case, I have to create something like to-do, list, do, undo, remove, rename. So this is the business that the application is trying to solve. At the first moment, I said, I started thinking about the web API, but I changed it to create the unit tests, and from the unit tests, create the implementation of the use case. And I needed some fake repository that was my in-memory. Later on, I changed it. Oh, let me create a web API as user interface. On the persistent, I created a file system, SQL Server, end up by hosting the data in a GitHub gist and using the final application as a console. So the UI was decoupled, the persistence was decoupled by design, and the use case haven't changed at all. And I have many projects on GitHub. Mostly are splitted on these 4 layers, organized on these 4 layers. But my suggestion to anyone that is joining the clean architecture, following test-driven development outside in, is to start with a test project, test against a core business, start implementing from there. If you need a dependence like a fakes, add infrastructure object, infrastructure project that you add your fakes there. Later on, if you need, if you are preparing your application to support multiple domains, you can segregate the domain and say, next thing that I'm gonna do is maybe I need to create a second subdomain. To wrap up and to focus on clean architecture again, is that use cases are the central organizing structure. They guide your implementation. And actually the tests guide your implementation. User interface and persistence should be designed to fulfill the core needs. I guess that we need to put some effort on decoupling the user interface, because what I've seen before is like we just don't decouple the user interface. Defer the decisions by implementing the simplest component first. And by references to share with you, I have this project I support together with these guys, the Clean Architecture manga. It's if you don't know, just check out. It's very interesting for .NET developers, or even other languages like Java or any object-oriented. And to understand completely the clean architecture, I always suggest to check the Clean Architecture book that we are giving away here today. Robert Martin videos on YouTube, like this Clean Architecture, and the Clean Coders, definitely. The Clean Coders series are very interesting to watch. I prepared, I was expecting 2 questions, but as we have 6 books, at least 6 questions. Ask a question, choose a book. Okay, let's make it civil.